Good morning, students. Let us solve some more numericals from chapter 2, page number 44. Questions based on ICSE examination. 7th question. A man of mass 60 kg runs up a flight of 20 steps in 20 seconds. If each step is 20 cm high, calculate the power developed by the man. See the figure. This is the man. His body mass is 60 kilogram. So his weight will be m into g. G is given as 10. So 60 into 10. 600 Newton is the body weight of the man. So while climbing the step, he has to exert an upward force equal to his weight. While we climb the steps, actually we are lifting our body weight in each step. So the force the man has to exert is 600 Newton, and finally he climbs 20 steps, each of 20 centimeter. Each step is of 20 centimeter height. Like that 20 steps are there. So total displacement is 20 into 20, that is 400 centimeter, that means 4 meter. The total displacement happening to the man is 4 meter, and the force exerted by the man is 600 Newton. So work done can be calculated by the formula F into S. F is here, S is here. So you will get the work. Then power you can calculate by the formula work upon time. Now same page 44, additional numericals. First question, a load of mass 100 kg is pulled up by 5 meter. Calculate the work done. Here work done is equal to gain in potential energy, that is equal to mgh. This is the formula you have to use. Now second question is also based on the same formula mgh. Here mg, weight of the man, is given as 300 Newton. H is given as 7 meter. Now question number 3. A ball of mass 200 gram falls from a height of 2 meter. What is the kinetic energy of the ball when it reaches on the ground? Mass of the ball is 200 gram. That is 0.2 kilogram. It is kept at a height of 2 meter. G value is given as 9.8 meter per second square. So you can find out what is the potential energy possessed by the ball. And according to law of conservation of energy, the potential energy possessed by the ball is changing into kinetic energy when it reaches the ground. So how much is the potential energy at the highest point? Same will be the kinetic energy while it reaches the ground. So kinetic energy of the body is equal to the potential energy possessed by the body at the height. Now question number 4. A body of mass 2 kg falls from rest. What will be its kinetic energy during the fall at the end of 2 seconds? So consider this as the body. Its mass is 2 kilogram. It is falling from rest means U is 0. Falls down. Suppose after a time of 2 seconds it reaches at this point. Here the final velocity you can find out. V is equal to U plus gt. Since body is falling towards earth, acceleration is g. U is 0, g is given 9.8 and time 2 seconds. So 19.6 meter per second is the velocity at this point. And you are asked to find out kinetic energy here. Formula for kinetic energy is half mv square. That is half into m is 2 into v square is 19.6 square. So do this calculation, you will get the answer. How much is the kinetic energy possessed by the body? Now question number 5. A body of mass 2 kg is thrown vertically upward with an initial velocity of 20 meter per second. What will be its potential energy at the end of 2 seconds? Suppose this is the body. Its mass is 2 kg. It is thrown up with a velocity of 20 meter per second. After 2 seconds, what will be its kinetic energy? Suppose after a time of 2 seconds, the body reaches at this point. Here V value you have to find out. Use the formula V is equal to U minus GT. Since the body is moving away from earth, minus G you have to use in the formula. We will get V. Then use the formula kinetic energy is equal to half mv square. Now question number 6. Two bodies of equal masses move with uniform velocities v and 2v respectively. Find the ratio of kinetic energies. For the first body, let the mass be m, velocity v. So its kinetic energy will be half mv square. For the second body, mass is same but velocity is 2v. So its kinetic energy will be half m 2v all square, that is half m 4v square. Take 4 outside the bracket, then remaining is half mv square. So you got the kinetic energy of the first body here and second body. Find out the ratio of these two. You will get it as 1:4. Question number 7 you can do by yourself. Same type of question was explained earlier. Question number 8 now. Calculate the power developed by a 110 kilogram man climbing up a vertical stairway at a rate of 2 meter per second. Here mass of the man is given as 110 kilogram. So his weight is m into g. Since g value is not given in the question, you may use it as 9.8 or 10. If it is given in the question, that same number you have to use. So here I am using g as 10, or you may use as 9.8. So his weight will come as 1100 Newton. This is the force needed. Force to be exerted by the man is 1100 Newton and the velocity is 2 meter per second. So power can be found out. Power is equal to force into velocity. Force into velocity, you will get it as 1100 into 2. Okay, you will get the answer in the book 2156 because this acceleration due to gravity they have used as 9.8. Okay, use here 9.8, then you will get it as another number. Okay, so this value you have to use. This is the force. Okay, so use that value here, then you will get the power. So formula is force into velocity. Next question number 9. A bullet of mass 30 gram moving with a speed of 400 meter per second penetrates 10 centimeter into a mud wall. What is the average force exerted by the wall on the bullet? Consider this as the mud wall. The bullet striking here, it's this is the bullet. Its mass is given as 30 gram. In kilogram it is 0.03 kilogram is the mass of the bullet. It strikes with a speed of 400 meter per second. That is the speed at this point while it strikes on the mud wall. Then this bullet went forward a distance of 10 centimeter. That means 0.1 meter. Then comes to rest. The bullet went into the mud wall. This rectangle you imagine as the mud wall. It went a distance of 10 centimeter it penetrated into the mud wall by a distance of 10 centimeter and stopped. Stopped means final velocity is 0. You are asked to find out what is the average retarding force exerted by the wall. Retarding force formula is mass into retardation. You know force formula is F is equal to ma. If the force is accelerating force, mass into acceleration. If force is a retarding force, mass into retardation. Mass is already given here 0.03 kilogram. Retardation, how will you calculate? You look at this diagram. You know the U value, V value and S value. So use the formula V square minus U square is equal to 2AS. V square is 0 minus U square means 400 square. That is 1,60,000 equal to 2 into A unknown, S is 0.1. So you will get acceleration as minus 1,60,000 upon 0.2. So this is the acceleration. So how will you get retardation? Retardation is minus acceleration, means this minus sign, if you just change, it becomes the retardation. So you got the retardation. This is the retardation value. Okay, so multiply it with the mass. Then you will get the retarding force. Now page number 45, question number 10. The lungs perform 2.4 joule of work during each expansion. How many times per minute do they expand if their power is 2 watt? Here power is given 2 watt. And the time is given 1 minute. That means 60 seconds. Power of the lungs is 2 watt and the working time considered is 60 seconds. So how much will be the work done? Work is power into time, 2 into 60. So it does a work of 120 joule within a time of 1 minute. Then the work for one expansion, single expansion is 2.4 joule. So number of times, how many number of expansions it makes, you can find out. 120 joule is the total work done and the work for one expansion is 2.4 joule. When you divide, you will get the answer as 50. So within 1 minute, 50 expansions it can make. Now question number 11. The heart does 1.5 joule of work in each heartbeat. How many times per minute does it beat if its power is 2 watt? Means power of heart is 2 watt. Then for 1 minute time, that means for 60 seconds, how much work will be done? That is power into time, 2 into 60, 120 joule. Then for each heartbeat, the work done is 1.5 joule. Therefore, number of beats equal to 120 upon 1.5. You will get the answer as 80. Next question. Question number 12, page number 45. A ball of mass 0.5 kilogram is thrown vertically upward with a velocity of 4 meter per second. Calculate the maximum potential energy it gained at the highest point. Mass of the ball is given as 0.5 kilogram. It is thrown up with a velocity of 4 meter per second. Look at the diagram. This is the ball thrown up with a velocity of 4 meter per second. So it possesses kinetic energy. That kinetic energy you can find out by the formula half mv square. Both m and v are given, so you can find out. According to law of conservation of energy, as the ball goes higher and higher, kinetic energy slowly changes into potential energy. And at the highest point, the full kinetic energy changes to potential energy. So potential energy at this point is equal to the kinetic energy at the starting point. So potential energy is equal to the kinetic energy, that is half mv square. I mean the kinetic energy at this point is equal to the potential energy at the highest point. Now next question 13. If the power of a motor is 25 kilowatt, what speed it can raise a load of 25,000 Newton? Here you have to use the formula power is equal to force into velocity. Here power is given as 25 kilowatt. Convert it into watt. So 25,000 watt. Kilo, the word kilo stands for 1000. Then The load lifted or the force exerted is 25,000 Newton. So in the given formula, P is given, F is given, V you can find out. Now question number 14. A machine raises a load of 1000 Newton through a height of 10 meter in 5 seconds. Calculate the power of the machine. Power is equal to work upon time. Time is given 5 seconds. Work we have to calculate. Work is equal to the gain in potential energy mgh. Here in the question, mg is given directly as 1000. M into G is given as 1000. Height is 10 meter. So you will get the work divided with the time, that is 5 seconds. Then you will get the next question 15. Same type of question was explained earlier, so you can do it by yourself. Now 16. A body of mass 2 kg falls from a height of 10 meter. How much energy it possesses at any instant? So how much is the potential energy? That is mgh. Same will be the energy at every instant, but the form changes. While it comes down, this potential energy will be slowly changing into kinetic energy, but the total energy at any instant is same, that is equal to the potential energy mgh. Now last question 17. That question also same type we have solved, so you may do it by yourself. Now chapter 2 is got over. Do the exercise questions in your notebook. Okay, thank you.